Hey guys, Mr. Mice here again, and this is the third video in 4-3, which is using start plus accumulation method. These are common problems in any AP calculus class, or in calculus for that matter. Even if you're not an AP, it's a pretty common problem. We call it start plus accumulation method. That's kind of a tagline for these types of problems. But it basically means that we're starting at a certain point and then we're accumulating something over time. And I like to say this is SPAM, SPAM, start plus accumulation method. So you can think of it that way. So you already know that the accumulation of something is going to be the area under the curve or the definite integral. And if we start at a certain part of that function and then we accumulate, it's called start plus accumulation. So it's almost like having an initial condition, but just slightly different. So let's take a look at a couple examples here. So first one here, if f prime of x, and I'll zoom in so we can see this problem a little better here. If f prime of x is equal to 3x squared plus 3, and f prime of 0 is equal, and f of 0 equals 4, find f of 2 without a calculator. Okay, so we're talking about start plus accumulation. And we know that we're using start plus accumulation because we are going to start at 0, okay, and then we're going to accumulate till we get to 2. All right. Sorry, something's been in my eye, I swear. All right, so again, how do we know it's a start plus accumulate SPAM problem? Is because we know that we're going to start, and I don't know if I said this right the first time, I'll repeat it. We're starting at 0. At 0 is x, and we're going to 2. So we're looking for f of 2, and we will start, our start would be at f of 0. Okay, so we're going to start at f of 0, and then we're going to accumulate all the way until we get to 2. So 0 to 2 of f prime of x dx. All right, so that's kind of what it looks like there. I'll take an f prime instead. I know f prime. F prime is 3x squared plus 3. Okay, so here now we're going to take the antiderivative using the fundamental theorem of calculus. I know what f of 0 is. F of 0 is 4. And so I'm going to use the fundamental theorem of calculus here, and I'm going to get x cubed plus 3x evaluated from 0 to 2. So I'm going to evaluate that from 0 to 2, and I'm going to plug 2 in here, and I'm going to plug 0 in, and I'm going to get 2 cubed plus 3 times 2 is 6, and that's going to give me 18. All right, so that's that's what f of 2 is going to be. So really what you got to think here is that, okay, so I'm looking for a value, f of 2, and I have a value that's less than that I know, and I can actually accumulate to that value when I do my my antiderivative. But we need to make sure that we're, the problem must look like we need to do an antiderivative, and these two examples do. So number 15 here, an object's velocity is v sub t equals 2 to the t. Find s of 3 if we know that s of 2 is equal to 8. So this is a SPAM problem, start plus accumulation, because we're starting at 2 and we're going to accumulate till we get to 3. So s of 3 is equal to s sub 2 plus the integral of 2 to 3 of v sub t dt, right? Because we're talking about position and we know velocity. So s of 3 is equal to s of 2 plus the integral from 2 to 3 of 2 to the t dt. Now, we haven't covered in my class yet how to do this integral. So when we're doing when we have an exponential like this, we haven't really covered it yet. So we're just going to use our calculator. And so in our calculator, first of all, we know s of 2 is 8. If we plug this in our calculator, it's going to give us, well, actually, you know what, we can do all of this in the calculator at once. And that's what I would recommend doing. When you're doing something like this in the calculator, I really do recommend you plug all of this in at once. So you do 8 plus integral from 2 to 3 2 to the t dt. And I went over that in 2 videos. So 4-A, I went over how to do this in a calculator. So you're just going to enter this in your calculator, and the calculator is going to give us something like 13.771. And that'll be our answer. All right, so start plus accumulation. You're starting at a value, a function value, and then you're accumulating to the value that you're looking for. Okay? All right, guys, that is SPAM. Catch you later. Bye.